In this video, we're going to look at how to do an Anova using Minitab. In my data here, I've already preloaded my data. I've got a data set that shows 4 different courses that I teach, 4 different classes of the same course, and I'm looking at a sample from each one. So I've got 15, 12, I got 13. I've got a different number of samples from each class. And if I look at the numbers, it looks like the class averages are fairly similar, the scores are similar, but my question is, I'm wondering if there is a difference in the means. Okay, so for an Anova, remember that our null hypothesis will be that there is no difference in the means, that the mean for class 1, class 2, class 3, class 4 will all be equal. We're testing to see if we can conclude that they're not all equal, that the means are not all equal. So to do an Anova, it's fairly simple. I like to put the title in this title block here, and then I have my data pre-entered. Just list your individual pieces of data in each class. Okay, so then I'm going to go to stat, Anova, one way. This is a one-way Anova. Okay, and then the default will be the response data are in one column for all factor levels. In the way I did this, my response data are in separate columns for each factor level. So I've got class 1, 2, 3, and 4. And just to show you the way that that would be, when I click on responses, you select the columns that you want. So I'm going to compare class 1, 2, 3, and 4. And then those will be my responses. And I could just click OK from here, and I will get the Anova. Notice my null hypothesis is that all the means are all equal. The alternate hypothesis that not all the means are equal, where the means are not all equal to each other. Alpha is 0.05. Okay, I'll show you in a moment where I can change that. Okay, we assume equal variances, right? That are null hypothesis. We assume equal variances. And here are factor levels. We've got 4 levels, class 1, 2, 3, 4, kind of restating the information we have. And notice that Minitab creates the Anova table. Okay, the factor is the classes, 3 degrees of freedom, right? Total, 63 degrees of freedom. And I'm not going to review exactly how to construct the Anova table or how Minitab constructs the Anova table, but the important values are that our F statistic, our F value is 6.62, and our P value is 0.001. So we can conclude that there does appear, we can reject our null hypothesis and conclude that it does appear that there is a difference in the mean for those 3 classes. Okay, more information down below. If you go down to the means here for each of the classes, you notice the sample size for each of the 4 classes, the mean for each of the 4 classes, and notice that class 3 here, the mean does appear to be significantly larger than the others. We've got our standard deviation, and then our confidence intervals for each. So we're 95% confident that the mean for all of class 1 is somewhere between a 74 and an 82, and so on. Notice that the lower end of the confidence interval for class 3 is higher than the upper end of the other 3 classes. That's kind of helps me see that. We've got our pooled standard deviation here of 7.79, and then we have an interval plot. Okay, so the dot, that's the mean for each of the 4 classes. Okay, you can find those numbers up above. And then the 95% confidence interval, okay, we had the mean 78.133. Notice when we hover on the confidence interval there, the estimate is 78.133. That's the mean with the confidence interval, 74.1 to 82.2. And that will show up for each of these 4 bars here, okay? And so there's the Anova using Minitab. Now, I did tell you that I would show you how to change your alpha value. If you go back to stat, Anova, one way, if you go to options, okay, we've got our confidence level. We can change our confidence level from 95 to 99, let's say. We're assuming equal variances for each of the 2 groups, and we're going to leave it 2-sided. We click OK. And then notice our alpha value changed. Okay, F value did not change, the P value did not change, but you'll notice if you had written these down that these confidence intervals here did change. Okay, and again, my graph changes there a little bit. My P value is still 0.01. We can still conclude that the means are not all equal to each other. We'll do a little bit more exploring here on the one way. results. Okay, you can see what's being reported here, the method, the factor information. That gives me all of these different pieces over here. For example, if I clicked on model summary, turn that off, I would not get this model summary information there. So I just always leave those on. Okay, in the expanded tables, we could do that, and this is going to expand those tables out just a little bit. Okay, so we get the contribution, which is the only thing that does. So that's not a huge factor. Okay, I don't bother to turn that on when I'm doing the Anova. Okay, you could select different graphs that you might want, like a box plot of your data. Okay, if we now click OK, notice it is all very similar. And what you're going to find is not just the conference enrolls, but you find the box plots for each of your data as well. So you can see that there's not a lot of skewness. Okay, these points, okay, that's the mean again, just like over here, mean of 78.133, mean of 71.133, and so on. This value here, this bar is going to be your median of 75. So you get the box plot as well as the mean, and you can use this to look for some skewness. So again, there's just a quick look at how to conduct an Anova using Minitab.